Dear student, in our continuous journey of combined spectra problem analysis, we had solved a combined spectra up to 1 to 7. We had discussed about the NMR value and a general procedure for the combined spectra analysis. And I had also uploaded one video for the HDI or degree of unsaturations or hydrogen deficiency index or double bond equivalency. Today in combined spectra problem analysis 8, I use a degree of unsaturation or HDI concept also at here. So let us start to solve a combined spectra problem analysis. So these are the spectral data it is given to us. It is written that it is UV transparent, no problem. The UV data is not that much also required for us. Molecular formula is given. A molecular formula is given carbon 5, hydrogen 12, and there is one oxygen only. From this IR, if I say this in IR, the value 3470 and 1150 are important because this is very common stretching of carbon-carbon, and it is present always because so many molecules have a carbon-carbon stretching. So these two are very important for us, I think. Let us go in NMR. So if I see this NMR, this is all the data is very important for me. And from that, if I see here, a total number of 12 hydrogens are there, and they are differentiated in a different way. One more thing is to say is very interesting is this one. This is very interesting for us. 1.14, that is a singlet. It is very interesting for us, and what type of the possibilities of this group in a compound, that also we discuss. Let us go to this molecular formula or a molecular weight of this compound. So according to the given molecular weight of this compound, I can say we calculate a du. So from the du, if I say this value is equation is 2c plus 2 minus h minus x plus n divided by 2. This is a degree of unsaturations formula, and from that I calculate what is the possible du. Then 2, a number of carbon is 5. If I see it here, plus 2, hydrogen is a 12, and in the molecular formula of a du there is no importance of uh, oxygen, so this du is 0. Du is 0, so conclusion is a compound is a cyclic saturated rated compound. So the concept of du or HDI, I had uploaded already this video. If you have not seen, then please see that. I come to the conclusion with the help of oxygen, what are the possible group or functional group is this OH and ether only. Because in case of carbonyl, it required a degree of unsaturations that required a 1. But in our compound, there is no du1. So these two are the possible functional group which I can see. So from that, which functional group present and a master spectroscopy to identify this functional group is an IR. So if this OH is present, then the chances of IR value is this one, 3470. So I can say this OH is present because nearer to 3500 centimeter inverse, if we are getting the signal in the presence of oxygen, then we can say the presence of alcohol is there. Let us go, and this chances of ether is very less because already alcohol is present. Now let us go ahead and see this NMR. So from this NMR, this is very interesting for me. If I say this one, and whenever you found that singlet with 3 edge, then I can say this is a possible group. Okay, this is one of the possible group. Second thing is I want to discuss is, after that it is okay, it is concluded, this is the possible group. One is this will give the singlet, and this value is 3.2, so the chances is OH only, because OH is already confirmed from this IR. So that is over. Now we will see about what this group will tell us. So from this group, if I see, then this triplet and this is a quartet. This is very famous ethyl group, CH3CH2. If I see here, then I can say for that I get a triplet, and if I say for that I get a quartet. Why quartet? Because this is splitting is based on n plus 1. What is n? N is a neighboring hydrogen. Now this is the possible fractions which we get from this NMR, IR and DU. So if we will calculate, the number of hydrogen is here is 3 plus 3 6 and plus 1 7 plus 1, then 3 plus 2, that is 5, that is 13. So I can say there is a less number of hydrogen, we are getting a more. So I arrange the fractions. So by arranging the fraction, I could get, this is CH3 and this is OH, this is CH2 and CH3. I hope this is the possible structure I can say. So here, after getting these values, we confirm this is a possible a structural formula, whatever the data is given to us. So let us see, this formula we are getting is CH3, CH3, then OH, CH2 and CH3. Let us confirm how it is concluded. This is confirmed from this degree of unsaturations and IR. Then this is confirmed from this mostly from NMR. This too is also confirmed from the NMR. So we arrange all this, and if we see here, this delta value of this two and this CH2. So for the CH3, CH36, their delta value is and a 2H hydrogen delta value. Compared to that, the 3H is very simple, so their value is near to 0. This two, I can say this three hydrogens, they are very near to the electronegative elements. So they are near to the electronegative elements, so I can say this delta value of this are a little bit higher, because I minus effect of oxygen that could increase the delta value. Among them, CH3 value is a less, and CH2. So this is methyl proton. This CH3 are methyl proton. Their value is little bit less. This is known as a methylene proton, and this value is a little bit more, I can say. And from that I conclude that the between the methylene proton and methane proton, there is 0.3 difference is there, 0.3 to 0.4, and we come to the conclusion that this is our final structure. Let us enjoy this online learning of combined spectra analysis. If you see this video, then give me a comment in a comment box, please. Thank you once again.